So this is an introduction into direct proportion. You might not have heard the phrase before, but you'll have certainly seen direct proportion in lots of different ways. And this example here is just showing you how you often come across it in shopping. So you've got the length of something here, it's a piece of wire, and its cost is directly proportional to that. And this symbol here means proportional to, so whenever you see that, it tells you that M, the length of the wire, is proportional to the cost. Now, it also tells them that they're directly proportional, which means as one goes up, the other one goes up by the same proportion, constantly, each time. So you'll see here that 2 lengths, 2 meters of wire cost 50p, and 3 costs 75p. And it keeps on going at the same rate. It's directly proportional. So in this situation, what you always find is that there's some number, which we in a minute will start to call k, that connects these two. And here that is that it's been multiplied by 25 each time. And again, the same thing's going on here. So 5 times 25, same thing here, that must be 125. 8 times 25 must be 200. And then I'm just going to be working backwards from this one. That would be just divide by 25. How many 25s go into that is 21. So that's how direct proportion works. Because I know the relationship between them, and it's constantly going up at the same rate for both of them, I can easily fill in these tables. So let's have a look at a question that involves setting up an actual formula, a link between the two. So 2 variables, v and t, no idea what they're all about, are directly proportional. When t is 8, v is 18, write a formula which links v and t in the form v equals something that will work for any number at all. So we're going to begin by using the symbol that we just looked at a minute ago. So we're going to write that v is going to be proportional to t. And I'm always going to write that the way it's written down in that order. And then I'm just going to stick the numbers in. Except I do know that some relationship, just like we had before, the v is always going to be equal to some number, which I'm going to call k, because in maths we use that to refer to a constant term, t. So some number k multiplied by t will always give me v. So now let's just stick these two numbers in from up here, and we can work out what that relationship between those two must be. So v is going to be 18, k is the bit we don't know, what connects the two numbers, and t is 8. So if I wanted to work out what k was, I just need to get rid of that times by 8 over there. So to do that, I just divide both sides by 8. And I'm going to get 18 over 8 over this side, which I could stick into my calculator and leave it as 2.25, or I could just leave it simplified down as 9 over 4. Either way is perfectly fine. Or you can call it 2 1/4, whatever takes your fancy. Anyway, so what I've done so far is I've worked out that value of k. But it says write a formula which links v and t in the form v equals something, which we've not actually done yet, even though we did it there. So all we've got to do now is take this value of k we've just worked out and stick it right back in where we started, so it's going to go straight back into there. So rewrite that, I've got v equals k, which is, I know, 2.25, lots of t. And that's always going to be the relationship between v and t for any values, because we know they're directly proportional. So that is the formula which always links v and t, given that set of numbers. Okay, let's have a look at another one. Can be quite wordy, some of these. So distance covered by a car d is proportional again to the time taken t. And because I know they're directly proportional, I know it's going to be d equals some number k times by t. Okay, that's got to be a relationship between those. So again, I'm going to go and work out what that value of k is, what connects the d and the t here. So I've just got to put these two numbers in, make sure I get them the right way round. The car covers 91 kilometres, so that must be d. So I'll stick that in there. And then on the other side I've got k, which is the bit I'm trying to work out, times by t, which is the time, 3.5 hours. So if I wanted to find out what k is, which is what we're aiming for, I need to get rid of this 3.5, this times by 3.5, and to do that I'm just going to divide both sides by 3.5. And if I do that, I get rid of that, and I've got 91 divided by 3.5 over here, which is 26, and on the right hand side we've just got k. So I still haven't finished the first bit yet. Write a formula which links d and t in the form d equals something. So again, I've got the value of k and I've just got to go and stick it back in there. And I've finished this first bit. So d is always 26 times by whatever t is, and that's the formula that connects those two. So that's the bit I'm now going to go away and use to do whichever bit comes next. So I can tick that first little bit off. How far does it cover in 2.5 hours? Right, this formula here now is all I'm going to use from this point onwards. You can kind of ignore everything else now. How far does it cover in 2.5 hours? So 2.5 hours is a time, so I'm just going to input that into the t. So I'm going to have d equals 26 times by 2.5. So I can put that in there. And 26 times by 2.5, sorry, is 65. That's that bit done. So it travels 65, and that's in kilometres. Take that bit off. And then the final bit at the bottom, if it travels 110.5 kilometres, which this time is giving me a distance, how long has it been travelling? So again, I'm going back to the formula which I've made, and I'm just going to put in this time a distance so I can work out the time. So in goes the distance of 110.5, and that equals 26 times by whatever t is. And that's what I need to work out this time. So to do that, we need to get rid of the 26 to get the t on its own. So we'll divide both sides by 26. And that will get rid of that. And that will leave us with t equals whatever 110.5 divided by 26 is. It is 4.25, so 4¼ hours. And that's direct proportion for you.